Okay, today we want to ask the question, what is a kilowatt hour and how do I use it? Kilowatt hour. So to figure out what a kilowatt hour is, we can just start by looking at what a watt is and looking what an hour is and seeing if that gives us any insight. So kilo just means 1,000. So some kind of unit thing going on there. Watt is a unit of power. Hour is a unit of time. And so a kilowatt hour is really a power times a time. Well, let's think about that for a minute. What's the actual definition of power? Power, if you remember, is equal to the energy expended, the energy dissipated, divided by the time. So it's joules per second. It's the rate of energy expenditure. So if you just look at it that way, power times a time is a unit of energy. In this case, if we're using watts and seconds, we're going to get a joule. However, if we're using kilowatts, which is 1,000 times bigger than a watt, an hour, which is 3,600 times bigger than a second, we're going to get a kilowatt hour. So a kilowatt hour is several 3,600,000 joules. That's all it really is. So how do you figure out kilowatt hours now that we know a kilowatt hour? And notice it's not a kilowatt per hour. People always write kilowatt per hour. It's not a kilowatt per hour. That doesn't really make sense, right? Because kilowatt is already energy per time. Watt is a joule per second. A kilowatt hour is just a weird, funky unit of energy, and it's way bigger than a joule. So let's say, do a simple example. Let's say I have a 60 watt light bulb, okay, and let's say I use it for 3 hours straight. How many kilowatt hours of energy? I know if I wanted to figure that out in joules, I would do 60 joules per second, and then I would convert 3 hours into seconds, and I would get the number of joules. However, that'd be a really big number. 3 hours converted into seconds is a whole bunch of seconds, and then that times 60 is a really big number, and it's too big. It's too big for most people to deal with, and it's certainly too big to print on your electric bill. So to get around that, we use a whole different kind of unit, the kilowatt hour. So the first thing we do, step 1, I'm going to come down here. We're going to convert 60 watts into kilowatts. Now, how do you convert 60 watts into kilowatts? Pause it and see if you can remember. How do I go from watts to kilowatts? You divide by 1,000. Whenever you want to convert something to something, you divide the original thing. Grams divided by 1,000 is kilograms. Watts divided by 1,000 is kilowatts. So if you do that, 60 divided by 1,000 is 0.060 kilowatts. It's already become a much smaller number. Then the next thing you want to do is say, okay, how many kilowatt hours is that? So I'm still going to do a power times a time, but this time I'm going to use 0.060 kilowatts times 3 hours. Okay, and that equals, 0.060 times 3. 0.18 kilowatt hours. It doesn't seem very much. See how much smaller that number is? If I had done that in joules, it would be a gigantic, ginormous number. So this is a much tinier number of kilowatt hours. Now, let's take this a step further. Let's say, step 3 over here, I use this light bulb 3 hours a day for an entire year. Well, how many days are in a year? That would be 365. So if I take that 0.18 kilowatt hours and I multiply it by 365, I get 65.7 kilowatt hours, which is a much bigger number. And you say, okay, well, that's well and good. What do I do with that? Well, what the electric company does is they actually look at how many kilowatt hours you use over the course of a month in your household. And then in Massachusetts, there's sort of an average rate for how much they charge you per kilowatt hour. If you look on your own electric bill, which I would totally encourage you to do, you'll probably see a number there. The average number in Massachusetts is about 21 cents per kilowatt hour. So if we multiply that by 21 cents, you get about $14, $13.80. Now, that's not a ton of money. $13.80 to keep a 60-watt light bulb on in your hallway or in the front of your house like 3 hours a day. You know, that would be about $26 if you were leaving it on all night outside. But then you start to add up every single thing in your house and you realize electric bills can get pretty high, and turning off that one light bulb is actually really important. Let's go on to the next slide. Let's see. How do I do that? Like that? No. Okay, so quickly just to review, to figure out the cost of electric energy, first you have an appliance that has some number of watts and you want to convert watts to kilowatts by dividing by 1,000. Then you're going to get the total time you use that thing in hours. You're going to figure that out. And then your last thing is going to be to multiply by the amount of the money, which you could figure out is usually given to you, but you can figure out is about, I would use 21 cents per kilowatt hour, which is the average rate in Massachusetts, unless you're told otherwise. Now, one thing to remember is you don't always have the watts. Sometimes you have to use your old-fashioned power equation. If you know the voltage applied to something and the current it draws, you can get the amount of watts. So for example, let's say you use a hairdryer that draws 8 amps of current or a device that draws 8 amps of current when it's at 120 volts. So the power is going to be 120 volts, that's the household voltage, times 8 amps, and 120 times 8 is 960 watts. Now that's a whole lot of watts, but that's the typical output of something like a hairdryer, washing machine, things like that. On your worksheet, there's actually a washing machine, and you could figure out how much it costs you to actually use that for a whole year if you do like 6 wash loads a week. That's one of the things that you're going to do. Again, now you would take that number of watts, convert it to kilowatts by dividing by 1,000, multiply it by the total number of hours you use it over whatever time frame, a month, a year, a day, just that one time, and then multiply by the cost. I hope this gives you a good insight as to how to calculate with kilowatt hours. And now go on and take a skim through the reading. It's really quick. It just talks a little bit about household voltages and things like that. And then you can try the 4 problems that I assigned you to do for a couple days from now. Okay, have a great day. See you later. Bye.